everyone. It is Sunday, August 11th, and you're looking at a live view of our Falcon 9 rocket, awaiting a 7:02 p.m. Pacific Time launch from Space Launch Complex 4 East in Vandenberg, California. Today's launch marks SpaceX's 76th mission of 2024 and 360th overall Falcon 9 mission to date. My name is Ronnie Foreman, and I'm a commercial sales manager here at SpaceX, joining you from Hawthorne, California, for our live launch coverage of the Arctic Satellite Broadband Mission, also known as ASBM, led by Space Norway. With just 13 minutes and 43 seconds to launch, let's dive right in. On board Falcon 9 today are two Northrop Grumman-built satellites, ASBM-1 and ASBM-2. These satellites will deliver continuous commercial and military broadband capacity to the Arctic region above the 65-degree north latitude. Today's mission is particularly exciting for SpaceX because this is the first time we will be launching to the highly elliptical Molniya orbit. In this orbit, the apogee, or the furthest point from Earth, is about 40,000 kilometers away, and the perigee, or the closest point, can be as close as 600 kilometers. The orbit is also positioned around the Earth by fine-tuning the inclination and argument of perigee, so that the apogee is as far north as possible. Now, the closer a satellite is to the Earth during its orbit, the faster it's moving, so that really high apogee allows vehicles in this orbit to spend a significant amount of time over the high latitudes of the Northern Hemisphere, making passes about every 12 hours, or twice per day. Then, with a perigee of just 600 kilometers, the satellite is moving much faster, and it zips across the southern hemisphere before popping back up to the northern side. That careful balance of timing and orbital positioning means that in the Molniya orbit, just two satellites are able to provide around-the-clock coverage of these northern latitudes. We have a great illustration of that orbit coming up, so with that, let's learn a little bit more about today's payload and mission.
The Arctic, a landscape of thousands of miles of floating ice, extreme temperatures, and magisterial beauty that has remained untouched for most of human history. We only reached the North Pole in 1904. A blink of an eye in the planet's lifetime, the world is changing fast, and so must we. The Arctic is growing in importance as governments, organizations, and scientists embark on vital missions. Airlines, shipping companies, and military vessels and aircraft are increasingly looking to northerly routes. In many cases, polar paths are more direct and save on fuel. And as the world changes, governments too are looking north to support further Arctic research, better understand the impacts of climate change, and be prepared for the future, whatever it brings. Connectivity holds the key to unlocking it all.
The need for high-speed coverage in the Arctic has been a priority for the Norwegian government for a long time. As far back as in 2006, the Norwegian government stated that the Arctic is Norway's most important focus area. We worked with several potential partners for a long time, but it became apparent to us that no single government or commercial company would be able to shoulder an investment like this by itself. The first piece of the puzzle came into place when a representative from the US Air Force approached me during a conference in the US and asked if there was room for a US military payload on board the ASBM satellite. After that,
Viasat
and the Norwegian Armed Forces were able to commit to the program.
The evolving operational environment drove an increased capability needed in the Arctic region. And now that the Arctic is more accessible, maintaining peace in the Arctic region is of the utmost importance. The partnership with Space Norway was explored because it addresses integrated deterrence and building relationships with our international partners and allies. With the growing strategic need for the North Polar region, we provide a more resilient capability. We provide 2 times polar SATCOM, and we've delivered this program faster and with significant cost savings.
The Arctic, a landscape of thousands of miles of floating ice, extreme temperatures, and magisterial beauty that has remained untouched for most of human history. We only reached the North Pole in 1904. A blink of an eye in the planet's lifetime, the world is changing fast, and so must we. The Arctic is growing in importance as governments, organizations, and scientists embark on vital missions. Airlines, shipping companies, and military vessels and aircraft are increasingly looking to northerly routes. In many cases, polar paths are more direct and save on fuel. And as the world changes, governments too are looking north to support further Arctic research, better understand the impacts of climate change, and be prepared for the future, whatever it brings. Connectivity holds the key to unlocking it all.
The need for high-speed coverage in the Arctic has been a priority for the Norwegian government for a long time. As far back as in 2006, the Norwegian government stated that the Arctic is Norway's most important focus area. We worked with several potential partners for a long time, but it became apparent to us that no single government or commercial company would be able to shoulder an investment like this by itself. The first piece of the puzzle came into place when a representative from the US Air Force approached me during a conference in the US and asked if there was room for a US military payload on board the ASBM satellite. After that,
Viasat,
and the Norwegian Armed Forces were able to commit to the program.
The evolving operational environment drove an increased capability needed in the Arctic region. And now that the Arctic is more accessible, maintaining peace in the Arctic region is of the utmost importance. The partnership with Space Norway was explored because it addresses integrated deterrence and building relationships with our international partners and allies. With the growing strategic need for the North Polar region, we provide a more resilient capability. We provide 2 times polar SATCOM, and we've delivered this program faster and with significant cost savings.
So Northrop Grumman is the prime contractor responsible for the satellite vehicle, the communications payloads, EPSR payload, as well as the EPS CAPS ground system. So we are providing the end-to-end capability that is the ASBM. In June, Northrop Grumman built 2 satellite constellations for Space Norway's Arctic satellite broadband mission, departed from our manufacturing facility in Dulles, Virginia. This was a sector effort as we provided all 3 major components to bring commercial broadband and protected military satellite communications to the Arctic. We proudly designed, integrated, and tested the ASBM space vehicles, which includes 2 flight-proven GeoStar 3 platforms and X-band and Ka-band payloads. We also provided a pair of EPSR payloads and the EPSR CAPS ground system for this mission.
With the launch today of the ASBM satellites embarking Viasat's GX10 payloads, we take an important step in providing broadband connectivity into the Arctic region. The GX10 payloads represent an important step in Viasat's evolutional network, providing broadband connectivity for mobility users no matter wherever you are, whether it's aviation, maritime, governments or scientists working in the region. Together through collaboration and teamwork, we're providing connectivity in the Arctic region that's been unavailable in the past, and this is a vital part in the evolution of Viasat's networks.
The ASBM program is a groundbreaking effort in an allied, governmental and commercial collaboration, both in a cost-efficient manner as well as showing how governmental and commercial needs can be met. We're already looking into new Arctic projects where we hope to bring in more of our allies, and we're looking forward to providing the first dedicated broadband services to users in the real Arctic.
The Falcon 9 on your screen is a 2-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It is the most flown U.S. launch vehicle ever, and also the first and currently the only orbital-class rocket capable of reflight. Now, starting at the top of the vehicle, which you can barely see through the fog there on your screen, we've got our carbon composite payload fairing, a protective shell that encapsulates the payload being sent to space. Just to provide a sense of scale here, the payload fairing that you can, again, just barely see on your screen is about 17 feet in diameter. It has enough room inside to hold an average-sized fire truck. The fairing is made up of two halves that will separate and jettison away from the vehicle once Falcon 9 reaches space. Today's payloads are, of course, the ASBM satellites, which were manufactured by Northrop Grumman. Continuing down the vehicle, we have our second stage. The second stage is powered by a single Merlin vacuum engine, or MVAC for short. After stage separation, the MVAC engine will ignite and carry the payloads to its final orbit. The Falcon 9's first and second stages are connected by the black interstage, which houses the MVAC engine's skirt and the system that decouples the two stages during stage separation. Below the first stage, which is powered by 9 Merlin engines, that provides the initial thrust to lift Falcon 9 off the ground and move the vehicle through the lower, thicker parts of the atmosphere. Each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust at liftoff. After stage separation, stage 1, which is also called the booster, will return to Earth using a combination of those Merlin sea-level engines and 4 titanium grid fins located at the top of the booster, which will guide it during its re-entry. The Falcon 9 first stage is also equipped with 4 landing legs that deploy just before landing to allow for vertical touchdown on either a landing pad or drone ship. For today's mission, we will be attempting to land this booster on our drone ship, Of Course I Still Love You, which is currently stationed on the Pacific Ocean. This mission marks this booster's 22nd launch and landing, having previously flown Crew 1 and 2, Sirius XM-8, CRS-23,
for strong-back retract.
IXB, Transporter 4 and 5, Global Star FM-15, ISI Aero C3, Korea 425, Maxar 1, and 10 Starlink missions. I'm not going to lie, that is one heck of a resume. And of course, prior to the start of our webcast today, the Falcon 9 team performed functional checkouts for both the ASBM payloads and the launch vehicle. At T-minus 38 minutes, the team concluded their go.
Strongback retract has started.
There's confirmation that the strongback is beginning to pull away from the vehicle. And of course, at this point in our launch lead up, the pre-valves between the first stage and the second stage are open. At the T-minus 7 minute mark, engine chill began to prepare the Merlin engines for flight. The first stage is connected to a launch mount at the base of the transporter erector, or TE, which is that truss structure you can see next to Falcon 9. We heard the nets call out that we are preparing for retraction here in just a couple of minutes. Just barely through the fog, you can see there that the strongback pulled away from the rocket by about 2 degrees. Now at T-minus 0, the ground hydraulic systems will pull the TE all the way back from 2 degrees to 45 degrees away from Falcon 9, so that it can have sufficient clearance to move away from the launch pad. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of rocket-grade kerosene fuel and liquid oxygen. Both stages will finish propellant loading about a minute apart from each other, so we're listening in now for those call-outs from Mission Control.
Stage 1 LOX load complete.
There's confirmation that we have finished loading liquid oxygen on board the first stage, and again, we are standing by for the same call-out for stage 2 in just about 50 seconds. You can, of course, always keep an eye on our mission countdown right in the middle at the bottom of your screen. That periodic venting sound you hear is normal. At this point in the countdown, we are venting chilled gas from above the LOX tank to maintain constant pressure in the tank as needed. Typically, for a launch, you'd be able to see that liquid oxygen condensing into clouds around the vehicle, but today, the best indication we have is that audio feedback coming from the launch pad. We are standing by for that LOX call out on board stage 2. At which point Falcon 9 will be fully loaded with 1 million.
Stage 2, LOX load is complete.
There's that confirmation that we have 1 million pounds of fuel on board Falcon 9. Now the next call out we're listening for is at T-minus 60 seconds that Falcon 9 has entered startup mode. That, of course, will mean that the rocket's autonomous internal flight computers have taken over the launch countdown. Then, just inside of T-minus 2 seconds, we will light the M1D engines for liftoff. At this time, the ASBM payload continues to be healthy, and the Falcon 9 team is tracking